Okay, so 5 out of 10. Not bad, but not good either. But that's okay because I understand it now. This problem, I missed a bunch of the conceptual problems, so I don't know how I'm gonna be able to write most of them. I mean, I'm just trying my best. Here's my pen. I lost my pen. Okay. Oh, I found it. Okay. So, this one I just didn't take into consideration the Newton's third law of motion, which basically means that all of these action reaction, all of these boxes have the same freaking magnitude. Yeah. Okay, let's go to the next one. This one. Okay. I think I just didn't read this carefully enough because it says the speed of block 1 begins to increase. Therefore, if the speed increases, friction increases. So, muse of A is greater than muse of B. And since the speed increases, the sum of the forces on block 2 will also increase because the acceleration increases. And in this one, if the little block has a speed less than gravity, then it's just going to fall off the track. If it's equal to gravity, then it's just going to fall off the track. It has to have a force greater than gravity in order to stay on the track. So like this. The next one was the elevator. Yeah, the elevator one. Okay, let's see. So, if the elevator is going down at a constant velocity, where's the speed? And the block of mass is hanging in equilibrium, as it gradually slows down, the elevator is going to have an upwards acceleration, upwards force. So it's going to pull on the string, therefore stretching the spring out. So x1 would be, it'd be greater than x1. Kind of like when a person stands in the elevator and when you feel that upward push from the elevator, it's kind of like that. So the spring basically has to exert a greater force than what's on the block, because the block, wait, yeah, because the force of the spring is equal to the force of the block. Yeah, it has to exert a greater force, therefore it's stretching the spring. Okay, and then this one I got. This one I just didn't use the formula. I didn't plug it in. We could just use v squared over r, or gm over r squared. I think since they gave us speed, I'm just going to use v squared over r. Just make things easier on myself. So let's see. 7,800 meters a second squared over 200. Oh, we have to convert that, right? Radius of the Earth. So what's the radius of the Earth? Like what, 6,000? Something? I don't know. Let's just do an estimate. Plus 200,000, and that should eventually, I think when you do the calculations, it should equal something like 9 point something less. I know it's less than gravity. I know it's less than 9.8, but yeah.